Have you ever opened a spreadsheet and wondered, can I actually trust these numbers? Many spreadsheet errors don't happen because the formulas are wrong. They happen because the data is wrong. Someone forgets to enter a value. An invoice number is entered twice. A payment is omitted. Or a record becomes disconnected from another worksheet. Once incorrect data enters a workbook, every report, dashboard, and decision based on that data becomes less reliable. Professional spreadsheet designers don't wait for users to discover these mistakes. They build control checks that continuously monitor the workbook and immediately highlight potential problems. Think of them as the spreadsheet checking its own work. Before we begin, you may also hear the term cross-check. A cross-check is simply one type of control check where two independent figures are compared to make sure they agree. In this lesson, we'll focus on control checks because they cover a much wider range of techniques used to build reliable spreadsheets. What is a control check? A control check is a formula or process that verifies the accuracy, completeness, or integrity of your data. Unlike most formulas, its purpose isn't to produce business information. Its purpose is to answer one simple question. Can this workbook still be trusted? That's an important design principle. Professional spreadsheets don't just calculate information, they continually validate it. Why are control checks important? Imagine you've spent days building an impressive dashboard. The charts look professional. The reports are beautifully formatted. Management are relying on the figures. Then one incorrect transaction is entered. Perhaps an invoice number is duplicated. Perhaps an amount is left blank. The dashboard still looks perfect, but it's now reporting incorrect information. Without control checks, you may never realize anything is wrong. Professional spreadsheet designers build systems that continuously monitor themselves. Let's look at some examples. Example 1. Missing transaction amounts. Let's begin with one of the simplest control checks. Imagine you've built a monthly business budget spreadsheet. Every transaction should contain date, description, amount. If somebody forgets to enter the amount, the totals become unreliable. Fortunately, Excel can detect this automatically with this formula. Count blank simply counts how many cells are empty. If the answer is 0, every transaction contains an amount. If the answer is greater than 0, the workbook immediately tells us that some transactions are incomplete. Spreadsheet design principle. Never assume important information has been entered. Always verify it. Now let's look at another simple but powerful control check. Suppose our invoice contains net amount, VAT, total invoice. These three figures must always agree. Net amount plus VAT equals total invoice. A simple if statement checks that relationship. If the figures agree, Excel displays pass. If they do not, Excel displays fail. Perhaps the total invoice has been typed incorrectly. Perhaps the VAT has been calculated using the wrong rate. Or perhaps someone has accidentally overwritten a formula. Whatever the cause, the control check immediately alerts us that something needs investigating. Remember, the check is not calculating the invoice. It is confirming that the invoice is internally consistent. Spreadsheet design principle. Whenever one value should equal the sum of two or more others, build a control check to verify that the relationship always holds true. Every invoice should have a unique reference number. If invoice appears twice, there's a risk of duplicate payments or inaccurate reports. A simple count if vote formula can detect duplicates automatically. Count if asks a simple question. How many times does this invoice number appear? If the answer is 1, everything is fine. If it's greater than 1, Excel has identified a duplicate. Spreadsheet design principle. Unique reference numbers are the backbone of reliable spreadsheets. Checking them should become standard practice. Now let's move to two more advanced examples taken from a school management workbook. Although the formulas are more sophisticated, the principle hasn't changed. We're asking Excel to continuously verify that our data remains accurate. There's one important question we need to answer. Can we trust the data? Even the best reports become meaningless if the underlying data contains errors. Professional spreadsheet designers don't wait for users to discover mistakes. They build automatic checks into the workbook. Let's begin by looking at the finished worksheet. Every time data is entered or updated, the workbook automatically checks every major area. If it finds a problem, it immediately reports it. Instead of waiting until someone notices an error weeks later, the workbook identifies issues as they occur. Let's test it. In the students table, I will make a deliberate mistake. I will change the student ID for Wilson Casey from a 6 to 1, the same ID as Alex Smith. Now, in an ordinary big workbook of this size, this error will probably go unnoticed for a long time, but in our workbook, it won't. As we can see here, this is an important spreadsheet design principle. Good spreadsheets don't just produce information, they also validate the information they're using. Our control checks worksheet follows a very simple design. Each check answers 3 questions. Has a problem been found? How many records are affected? Does someone need to investigate? Managers don't need to understand the formulas. They simply need to know whether the workbook is healthy. The formulas do the technical work behind the scenes. Let's look at some of the formulas that achieve this. Our first control check looks for duplicate ID for students. Every student should have one unique student ID for themselves. If 2 students share the same ID, attendance, assessments, payments, and lookups could all become linked to the wrong student, as we saw in our little experiment. This is exactly the type of problem a professional workbook should detect automatically. Here is the formula. Although the formula looks complicated, it follows a simple process. Before we explain the formula, there's one important point to understand. Sum product is an array function. Unlike many Excel functions that work with one cell at a time, sum product is designed to work with entire ranges of cells, known as arrays. Instead of checking one student ID, Excel checks every student ID in the table during a single calculation. You don't have to tell Excel to repeat the calculation. As soon as sum product receives a range instead of a single cell, it automatically performs the same calculation for every row. This makes it ideal for analyzing large datasets. The basic structure of sum product is very straightforward. It just takes a series of arrays or cell ranges. Think of each array as one set of results. Each array returns a value for every row in the table. Sum product then combines those arrays and returns one final result. In this workbook, we're using sum product as a counter. Its job is simply to count how many records satisfy the conditions we've given it. So, let's look at the formula which identifies duplicate student ID. Step 1. Count it. This is another example of an array calculation. The first range tells Excel where to look. The second range tells Excel what to count. Because sum product is working with arrays, COUNTIF performs the calculation for every student ID. Instead of asking how many times does this one student ID appear, Excel asks how many times does student 1's ID appear? Student 2's, student 3's, all the way to the last student. Most student IDs return 1. If an ID appears twice, Excel returns 2. Step 2, greater than 1. The next part asks a very simple question. Does this student ID appear more than once? If the answer is yes, Excel returns true. Otherwise, it returns false. So picture this. The formula now will be returning a range of true and false. False, true. False, and so on. And the minus turns these into a series of 0 and 1. Now for part step 3. Finally, sum product counts all the true values, all the ones. The result is the number of duplicate student IDs in the workbook. Notice what we've done here. Instead of expecting users to discover duplicate IDs, the workbook finds them automatically. Professional spreadsheets should always identify problems as early as possible. Let's look at another example. Our next control check example verifies that every student is linked to a valid guardian or guardian record. A missing guardian record could prevent letters, invoices, or emergency contact details from being retrieved. Let's make a deliberate mistake and see if the workbook picks it up. So in the student's workbook, we can see that Casey Wilson Guardian ID is G005. Let's go Guardian Worksheet and change that 5 to 555. Has the error been picked up in our Check Controls worksheet? Great, yes, it has. Again, this is a design principle. Every relationship between worksheets should be validated. The formula is here. Although the formula looks long, each function performs one simple job. Step 1. Match function. Think of match as a search function. It looks for a value in a range and returns its relative row position. So for every Guardian ID in the student's worksheet, Excel searches the Guardian worksheet looking for exactly the same Guardian idea. Again, because sum product is working with arrays, match repeats the search automatically for every student. Step 2 of the formula. If match finds the Guardian ID, everything is fine. If match cannot find the Guardian ID, it returns the n/a error. The ISNA function simply asks, did match return n/a error? If it did, ISNA returns true. That tells us the student has an invalid or missing Guardian ID. Step 3 of the formula. Finally, sum product counts all the missing Guardian IDs. If the answer is 0, every student is correctly linked. If not, the workbook immediately alerts the user that records need investigating. Spreadsheet design principle. Notice that we're not checking individual values. We're checking the relationship between two tables. One of the most common causes of spreadsheet errors is broken relationships between linked worksheets. Professional spreadsheet designers validate those relationships automatically. The individual control checks return numbers. Our dashboard converts those numbers into something much easier for managers to understand. If no exceptions are found, the workbook displays pass. Otherwise, it displays fail. Sometimes the simplest formulas produce the clearest management information. Managers don't want to read 20 separate checks every morning. Instead, the workbook summarizes the health of each major area: students, guardians, attendance, assessments. If every section passes, managers can have confidence in the reports and dashboards throughout the workbook.
Whether you're looking to improve your own Excel skills or train an entire team, we've built a practical course for real-world Excel users. Our 6-level online program takes learners from beginner to advanced and now includes using Excel with AI, ensuring every skill level is covered. For businesses and universities, we support groups from 3 users to over 1,000. Managers can track progress, monitor results, and see team performance in real time. Course levels include online exams, and learners who achieve 75% receive an automatically generated CPD-certified Excel certificate. Individual and corporate group licenses available. Learn Excel. Work faster.